So today we're actually going to start talking about how scientists actually learn about the things that they want to study. They will always follow the same method. It's a series of steps that scientists are going to use to answer the questions they have and to learn new things about the world around us. And all scientists will actually use this. It does not matter if they're in the field of biology, we're doing baby biology, or if they're in the field of medicine, chemistry, physics. If they're wanting to learn new things, they're going to do some of the same basic steps to find answers, no matter what that is. And that method that they use is called the scientific method. Now, the scientific method is what all scientists use to answer questions. The steps they follow are always going to be the same. Now, they might look a little bit different in different sciences, but it is still going to be the basic same series of steps. The first steps to the scientific method is to ask a question. Scientists want to know about the world around them, so they will ask a question, and that question defines the problem that they are trying to solve. They will then do research. Now, a lot of times we don't talk about the research step, but it's pretty important. In research, you need to do this in order to learn as much as possible about the problem so that you can then make an educated guess. And that's creating the hypothesis. Now, if you just go out there and say, well, I think it's because blah, 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 okay, you're not educated. And so you're not actually creating a hypothesis. Your hypothesis needs to be an educated guess. And of course, the way you get educated is you do some research and find out what other scientists the world over, as to the best of your ability, already know about the question you're asking. Next, you create that hypothesis. Now, when you create a hypothesis, that is a possible explanation that must be testable. Basically, the hypothesis is an answer to the question. Okay? How can I make better grades in science? If I study 1 hour every night, I will make better grades. You're actually answering the question before you actually have data. And that's what it's supposed to be. Okay? It's supposed to be an answer to the question that you can then test, create an experiment for in order to see if you are right. And then that will be the next step. It's actually doing an experiment. Now, if your question was, how can I make better grades in science? And your hypothesis was, if I study 1 hour every night, I will make better grades. You can test that. How would you test it? Well, you go home and you study 1 hour every night. That's how you test it. Okay, so your experiment would be to study every night and see if you make better grades. So this is what tests the hypothesis. It must be repeatable. You have to be able to do this over and over and over again so that you can see if you get the same results every time. Must be repeatable. And this is also where you would write out your procedure. And y'all, we're going to talk about writing procedures. You're going to learn about writing procedures. A procedure is the step-by-step process that you use to answer the question. You have to write the procedure. Y'all, without having a very carefully written out procedure, you can't repeat the experiment. And that repetition is what you need. The goal when you create your experiment and you write your procedure, you want to be able to take your test, your experiment, and give it to someone in another country even. Someone who doesn't even speak English. Translate it. And they will be able to do the same experiment the exact same way you did. That's the key to a good experiment, is it's repeatable and it's always done the exact same way. So when you're writing a procedure, it's got to be very clear, okay? At 6 o'clock at night, I'm going to put on soft music. I will organize my books. I will organize my notes. I will then start studying. I will study for 1 hour, taking a break every 15 minutes to watch a YouTube video. At the end of 1 hour, I will close science. Okay? Now, someone else can study the exact same way you did and see if it helps them get better grades in science too. Must be very, very clear, step by step. The other part of doing the experiment is observation. These two kind of go hand in hand because while you are doing your experiment, you're collecting data, okay? And that's the observation portion, okay? You have to watch what's happening while you do your experiment. If you're trying to make better grades in science, you're going to start watching your test grades or your quiz grades, and you're going to see if your grades are staying the same no matter how much you study, or if they're getting better, or hopefully not getting worse. All right, but you're going to collect that data, and that data is going to tell you what's happening with your experiment. All right, and then after you've run the experiment, however long you need to, whatever it is that you need to do, collected all your data, you've got to analyze that data and draw conclusions. Now, what you're looking at when you analyze the data is you're literally seeing what the data told you. Did your grades go up? Okay, then your data supported your hypothesis. Okay, if your grades stayed exactly the same, well, they didn't get better. So your data rejected your hypothesis. That data is going to give you information about whether or not your educated guess, your hypothesis, was on the right track, it was supported, or whether you were on the wrong track and it was rejected. Okay? So an example of the scientific method can be found at this site. There we go. So this just gives you some ideas about how it works in person. So if you go to my PowerPoint on your portal, you can click on this site and open this up on your own computer, and you can work your way through these. It just talks about what the process is, examples of good hypothesis and bad hypothesis. Talks about walking your way through the experiment, setting up the experimental group and the control group. We'll be learning about those. All right, about collecting data, and then about actually organizing your data and then using it to analyze and draw conclusions. Okay, so just an example out of a real science experiment of things you can do. All right, hope that helps, and we'll be working with this quite a bit over the next couple of weeks.